It's another exciting day here in Algebra 2. Today we are going to be looking at inverses, specifically quadratics and square roots, and then later on cubic and cube roots. So starting with quadratic and square root, quick refresher, how do you find the inverse? That is by switching x and y. So we are going to do that with functions and with graphs today. And then again, the notation for inverse, so if my original function was f of x, the inverse notation would be f to the negative 1 of x, or g to the negative 1 of x. Whatever your original function was, that negative 1 power means the inverse. So we're now going to look at finding inverses from a function. So starting with this first one, remember f of x is your y, so I'm going to switch the x and the y here and use algebra to get y by itself again. So the first thing I would need to do is subtract the 3. And then to get rid of the square, I need to square root both sides. And then the final thing that I would do is add the 2. So y is going to be the square root of x minus 3 plus 2, which means my inverse, f to the negative 1 of x, is the square root of x minus 3 plus 2. Now, let's think about something for a moment. Domain and range, thinking to our parent function. Again, f of x is our parent function, so I'm going to pull up Desmos. I'm going to put in our original function f of x. And if we look at this graph is in red now, our domain, we have all the x values, so our domain is all real numbers. But our range, our y values start here at the vertex, which is 2, 3. So the y values are when y is greater than or equal to 3. Now, if I were to graph my inverse function now, instead, I'm going to take that one off of here. Square root of x minus 3 plus 2. Notice we now have this blue graph. Our domain is not all real numbers any longer. Our x values start at 3. So our domain is going to be that x is greater than or equal to 3. And our range is no longer starting at 3. Our y values start at 2. So y is going to be greater than or equal to 2. So when we are taking inverses with quadratics and square roots, we are going to have to pay attention to how our domain and range changes. So let's do that again on the next one. I have a new function, g of x, and remember that is my y values. So switching the x and the y here, I've got x equals the square root of y minus 5. To work to get y alone again, first I want to square both sides now to get that out of my radical. And then the last thing I would do is add 5. So x squared plus 5 is going to be our inverse, g to the negative 1. And I'm going to pull Desmos back up so that we can look at the domain and range for our original function and our inverse function. Take that off of here. So here is the original function. Oops. Let's try that again. There we go, x minus 5. So our green graph, our domain, our x values start at 5, so x is greater than or equal to 5. And range, our y values start at 0, y is greater than or equal to 0. And now if I graph my inverse instead, which was x squared plus 5, looking at this purple graph now, my domain is now all real numbers, and my range is y values greater than or equal to 5. Okay, now let's look at inverses from graphs. Again, you are still switching x and y, but you are going to look at points on your graph and flip the coordinates to plot the new function. So I'm going to start looking at the graph on the left, which we are calling h of x, and I'm going to identify some whole number coordinates here that I can switch. Okay, so starting with negative 3, 5, switching that would be 5, 3. And then here I have 1, 6, switching that would be 6, 1. And then over here I have negative 1, 10, switching that would be 10, negative 1. And then here I have 5, 6, switching that would be 6, 5. And then lastly, 7 7, 10, switching that would be 10, 7. Now, if I were to connect these dots and make a horizontal parabola, what I would no longer have is a function. Remember, a function needs to pass your vertical line test, and if I were to graph that and draw a vertical line, it would cross twice. So what we have to decide is, are we going to have this going up? And again, this would be a square root graph, so that's what our square root graph looks like, or we could have it going down and have the underside. We can't have both. We would have to have one or the other, and that's why we have that domain restriction. So if we think about our original graph, the domain was all real numbers, and our range was y values greater than 5. Looking at our inverse now, our domain, our x values start at 5 and go on. And then our range is going to depend on if we're doing the upper or the lower. I graphed the upper solidly, so I'm going to do the domain for that one. And that is x values greater than or equal to 3. Or sorry, y values greater than or equal to 3. If we had done the underside, it would be y values less than or equal to 3. Okay, one more time. We have, one more graph here, k of x. To graph that inverse, I'm going to start looking for points that are whole numbers that I can graph. So -2, -5, that would switch to -5, -2. 2, -3 switches to -3, 2. And then 7, -2 would be -2, 7. So I can connect these dots and get that half, and if we were to mirror this, we could see what the other side of our parabola would look like. But back to our original function, the domain of that, the x value started at -2, so x was greater than or equal to -2, and the y value started at -5, so y was greater than or equal to -5. The domain for my new graph, because we only have the right-hand side here, this is x values greater than or equal to -5. And my y values start here at -2, y is greater than or equal to -2. Okay, that is our inverses for quadratic and square root. I will be doing the cubic and cube root in a separate video.